Let's get started. All right, so I grew up in the 80s, and the version of AI that we were sold back then was usually pretty grim. If you look at things like HAL, which is interesting, a ROT1 out from IBM, the crazy computer that took over the ship in 2001. One of my favorite movies to see as a kid was The Terminator. Inspired me to buy expensive sunglasses. I had those exact sunglasses there, but everybody else kind of had a grim output. And of course, Roy Batty from one of my favorite sci-fi movies, Blade Runner. And it seems to be that all of our lessons, maybe on what it is that we do as human beings, were really to look at kind of the bad side of what it was that our technology affords us. And we do see sort of patterns of that within all of our advanced systems. But it's highly possible that if you ask ChatGPT what the future looks like when you combine humans AI, the picture is actually a little bit happier than what it is that our sci-fi folks are talking about. And so how do we create a little bit more harmony within the AI systems that are working with us as tools? But how are we doing? It's not like AI is like a completely new type of thing. For people familiar and are not familiar with the term FANG or MANA here, that's Facebook, Apple, Amazon, Netflix, and Google. These companies have been using AI to a great extent for almost about 30 years now. And the vast majority of what it was that they were able to get from a business side of things is usually around deep customer engagement. So before I came to HashiCorp, I worked in the ad tech industry and got to see a lens of how it is that some of these systems work for engaging with customers. And if you look at somebody like Facebook, the social media explosion, how do we engage with their customers to connect them together even better? Amazon, obviously, with product recommendations inside of there, plus all the work on the cloud side of the business. Netflix recommendation service came out in 2000 for the DVDs, well before they even had an actual streaming business inside of there. And of course, Google, being the largest advertising firm in the world, being able to put together all of your user behaviors into something that allows you to engage with them from an advertising perspective, but also allowing other firms to be able to engage with their customers as well. If we maybe not have a big surprise, if you look at analyst information like Gartner, for instance, one of the top priorities for business executives is really around how do I improve that customer engagement and experience and retention within our environments. Again, very similar to the type of engagement goals that you see within the FANG or MANA companies. I'm kind of surprised that revenue growth is actually a little bit lower, but I would imagine that if you have good customer engagement, that also leads into further revenue growth, but maybe through other channels. Cost optimization in the cloud, maybe that should be a higher number, and then business continuity kind of rounding it off at 7%. The rest of it's probably people just kind of figuring out what the heck it is that AI is doing in the first place, right? If I were to ask the actual AIs or the large language models that are out there using both Claude and OpenAI, maybe not surprisingly that the results of what it is that these AI systems are suggesting are very, very similar. So customer retention also inside of their operational efficiencies, a giant goal for folks as well. And then getting down to cost reduction and more personalization. It looks like ChatGPT is a little bit chattier, I think, than Claude Sonnet, but we have those little bit of differences in between those. Okay, so if we kind of boil this down into a brief history lesson, the generalized artificial intelligence is just this idea of like, how do I take information from externalized systems and turn them into something useful for us without having to do a bunch of programming in the middle of that. And successively, this has turned into different iterations of progress within these. So machine learning had the ability for us to take large data sets and be able to categorize things into areas so that humans could actually label that data, so that now we get to understand what the difference between a cat and a car and all the rest of the objects that it's categorizing that are out there. The next step, of course, being applying the same type of techniques, but using neural networks to then auto-train those models so that they are starting to get a little bit more context for all the relationships between the various objects that they're looking at from a data perspective, and not having to have so much human training inside of there. And the last step, of course, and the thing that I think is why everybody is so interested in artificial intelligence these days is really because the large language models and some of these foundational models are not only able to understand and categorize that information, but they actually kind of repeat the capabilities of what it is that you want back. So if you draw me a picture of AI in harmony with human beings, it can go off and do that. And in some cases has some minor hallucinations here and there. But the idea being is that successively, with larger data sets and with larger compute capabilities within our environments, we're getting closer and closer to something that we would think of as being artificial intelligence. I can talk to the thing and it has some way of reasoning and returning information to me that's actually useful for a context other than like a parlor trick, something along those lines, right? So I have a theory about large language models. I've been sort of sharing this with a handful of folks recently, and that is really that the large language models themselves are not necessarily the end-all be-all of the AI systems in which we're going to employ within our businesses. They're kind of like a translation layer, a router, if you will. They take human intent, understand what it is that we're trying to grok or glean from information that we're sending to them, and then very, very possibly sending that off to other subsystem AIs that are special built on the back end for doing specialized jobs inside of there. And I'll give you a couple examples here. But the idea being is that our focus on the large language models, at least getting understanding of how these things operate and the data that we need to feed into them, is just kind of the stepping stone for us to be able to integrate them, which are much larger business processes in the long run. So what does this look like? If we kind of break down the AI sphere into a couple distinct categories, there's really only like 3 places I think that we need to be focused on right now. And the first of which is something in which you probably already have. You have a ton of data that is inside of your data stores. You're collecting data from sensors and all kinds of endpoints and producing that data and sending it to these data stores to be then processed by what other applications that you have inside your environment. So whether the streaming data or whether it's stuff that's being input by humans, you're scraping these things from your file systems. The first discipline, and we already have these inside of our environments, is how do I create these robust data structures for then feeding into the AI models, which may be numerous in nature. So here at re:Invent, we've got a bunch of different announcements around all the different AI systems inside of there, like the Q and the Bedrock areas of things, and then even being able to feed that into other large language models or other foundational models that are run by other companies. And I'm going to come back to the tuning and alignment thing in a bit here as I talk after the agents piece of it. But the backside of it is once I have all that data, once the AI models have been trained and sort of understand my particular business context, is then what do you do with that? And right now we're outputting videos and we're making some intelligence designs, or we're engaging with our customers a little bit better. But I think we're going to take this a much step further. And I think this is, again, towards the direction I think we're going to see is a lot of these models are going to become specialized for specific purposes. How do I run my industrial systems and my robots inside of my factory floors? How do I create better security systems for both physical as well as my digital IT systems? Again, customer engagement, a large focus for those things. But even down to like humans, we have a lot of jobs that are likely going to be controlled by humans for some time yet. Where I don't know that we're going to get AI plumbers anytime soon. Maybe we will. But the idea being, how do we actually help our humans inside of their jobs to do better, to understand problems better, and to get better quality out of the systems in which they have. So, we have these kind of elements, but I think another major area of focus for us as we begin to consume lots of different technologies, whether they're SaaS or inside of our clouds or run inside of our data centers, how do I hook all these things together in a secure way that allows me least privilege authorization, both in the scope and in the time dimension, but also like limiting the ability for any of these subsystems to both talk and control each other. As we begin to relinquish the control to AI systems, especially some of these subsystem agents, how do we ensure that they actually have the capability of doing the jobs that they're supposed to be doing? The downside is from the analyst side of things, they're witnessing that a bunch of people's AI projects are failing. And it's probably not a big surprise. A lot of cloud initiatives failed when people started going to the clouds in the early days of the cloud. We're still in the very sort of early ages of some of these large models being able to produce some business context for us. And about 30% of AI projects don't get past the pilot stage. So why is it that people are having such a hard time with this? Is it it just that they aren't properly scoping? Are there other technological challenges that need to be addressed to do this? And of course, we have a particular opinion about where that is. So hi, I'm Jake Lundberg. I'm a field CTO here with HashiCorp, joined by my esteemed colleague, David Wright, who is a cloud technical lead. And we're going to be talking through infrastructure at the speed of AI. Before I hand it over to David, I'm going to close out with a couple things. There are some clear patterns that we see, whether it's from people who are doing sort of cloud initiatives or AI initiatives as well. All of the people who are successful at doing this think about these as engineering projects from the get-go. How do I build the most solid foundations for the most cost-effective and the most sort of optimized workloads that I can have, and then be able to securely, again, connect all those various pieces together, because it's highly likely that those subsystems that you're going to be working with are distributed across a wide variety of vendors, unless you happen to be doing it all within one particular cloud. And then lastly, once you have those golden patterns, those things that you know that are working for specific parts of your business, how do I then take those repeatable patterns and then kind of spread them out throughout the rest of our organization so that we can scale out all the lessons that we've learned in these previous iterations and empower the business going forward. So let's take a look, David.
Cool. Thanks, Jake. So Jake outlined those three kind of key things and three areas where all organizations, regardless of what they're trying to achieve as their business outcome, are actually struggling with. So building the foundation. So how do I get that first part and that first step? Now, I grew up in a construction family. For me, building foundations had a very distinct meaning before I got into IT. You had to have all your tools. You had to gather all of those tools together to be able to do that and know how to use those tools in a very specified way so they didn't cut your arms off. You then had to have a set of plans. You had to have it organized and create some blueprints to actually understand what it is you're trying to deliver for the customer. And then you had to put those together to actually understand and build and achieve that deadline. So for me, when we think about putting these things together, these foundations are understanding what are the tools that are available. So, we have from HashiCorp, we have the infrastructure as code, we have Terraform. It's well supported across the AWS resources. It has, it's been used well over 3 billion downloads now? So it's well established. It's a well-known product, that tool that you can use. But how do you fit that into this new world order? Well, when we think about infrastructure and infrastructure at the speed of AI, particularly as AI is changing, when we think about, I think about in the last 12 months of what I have read, what I've tried to keep up with, how models are being deployed, how we're using it, all of those have pivoted and changed. There's been different, you now do it this way, you now do it that. And a lot of that is actually means that you have to be able to iterate, you have to be able to deploy quickly, you have to make changes, you have to be able to keep insight into what's going on, track where it's being deployed, and actually have the skill to actually be able to do this. And so thinking about how you can use the tools in this way to make sure you can get these constructs is obviously really important. And so having a platform where you can have a whole bunch of tools that can be used, again, gathering those tools together to understand what it is that you need to do. We have Terraform, Packer for images, Waypoint for standing up, Nomad for scaling, and you can tie all of these tools together. And so now I've got my tools, I need to think about what's the blueprint? What is it I'm actually going to deliver and build and create for the customer? And so when we think about this, the first part of this is obviously infrastructure as code. So how do we put together that tool and leveraging the infrastructure as code? We then think about the version control. So how do we have a single source of truth around what that tooling is going to be? So how do I understand what all of those things are going to be? How do I understand where I put that? Is it going into GitLab? Is it going to be into some other repository? How do I create a single source of truth to understand how my team can actually work and deliver this outcome? Then we have to think about data management. So what are the storage solutions we're going to put in together? Are we using S3? Are we going to use EFS? What sort of storage are we going to use? And then how are we going to get that data into there? So how are we going to ingest it? What's the ETL we're going to use? Are we going to, do we need to classify that data? How do we put that context in? Is there anything we need to do to manipulate it? And then we start getting into the next level of construct around computer resources, scalability, how am I going to make sure I can meet capacity, GPU, TPU, what sort of instance size are we going to enforce, how and what mechanisms are we going to put into place. Then we start getting into the security and compliance, thinking around how do I tie together the right compliance criteria around this, not just from the data structure, but how is it going to be used? Does it have to meet any kind of regulatory constraints? And moving into the areas where we have to think about other tooling, such as, are we applying AWS config, CloudTrail? Is there anything that we fit into those areas? Secrets management, obviously, again, HashiCorp Vault is a particular another way, which I'll talk about a use case and a scenario, particularly in a way of thinking about applying this when we get to our security section. Then leaping into monitoring and logging. You got into CloudWatch, or we're taking it into some other platform that is monitoring across the entire suite. And then thinking about how we communicate this. Because one of the challenges of this is skills, right? So you don't want to create a hero project that only certain people use and then fall into that trap of your hero project never scales because you cannot get either people to understand it or use it correctly, and the outcome that you're trying to achieve, like that business outcome that was initially the reason why you got all the finance to actually stand up this infrastructure, then doesn't actually meet that criteria. And so there's a lot of elements to put together into that blueprint to help you think about how do we drive this infrastructure change, which fundamentally is, right? All we're really talking about is how we stand up the environment to deliver these business outcomes. Having a great partnership, obviously we have a whole bunch of resources that we can use. There's the AWS provider, there's the AWS CC provider as well, so there's a whole bunch of work being done with Cloud Connect, the Cloud Connect element, so there's lots of different resources that we can put into this, leveraging things like Amazon Q for Terraform as well, being able to write and create the code in that construct, being able to start putting your modules together. And putting this into a real-world perspective, we've seen a consulting firm that we work with that have actually used this to actually increase their specific AI ML go-to-market. So they've used it as a 5 times increase to actually drive and deliver those types of philosophies across their customer base. Where I think about this in a real value perspective is going back to that construction analogy again, is we have the foundations, we now have a blueprint, we understand. We now can leverage some pre-built elements. So for me, thinking back again to my youth of moving and humping blocks for my dad, anything that was already prefabricated that we only had to move once was saving my back. So how can we actually reuse stuff that has been done, and how can we use that to our advantage? So when we think about what we need to build for these types of environments, where people say, I want you to now be responsible for standing up our AI environment, which means that you now have to take on data and potentially multi-cloud or hybrid cloud scenarios, and we need you to access all of these elements, and we need you to ingest it, follow that blueprint, put all those things together. There's a lot, right? And there's a lot to think about and understand and how to do that. If we can pre-consume that with verified modules and use a simplified workflow that integrates that delivery so that the outcome that you're trying to achieve is already pre-built, all you need to do is tune it and think about the input constructs that you need to build, you can now start to think about how you can deliver this across an organization in a repeatable format. So we take, from an example of this, which builds an AILM ops pipeline. So this builds the full construct. So this example will stand up a full scenario. This was built in conjunction with AWS. Gives you all of those blueprint elements that we talked about. So it sets up your version control. It thinks about how your login is. It thinks about all of those elements and puts it into that repeatable workflow. So now that get started first step, that is, the hardest step of climbing any mountain is the first step. That first step is now been done for you. So you're getting an aid, you're getting the snowshoes put on for you to actually start taking those steps up the mountain and using that to accelerate your business outcomes. So not only now from a technology perspective can you have an easy start, from a business perspective, you can also get an outcome that you can take back to the business and start showing the success to expand this across the rest of the organization. And so as we then think about that next element on, so we hit into that security challenge. And the security challenge is very well defined, right? Now, security is a primary concern for every cloud operator. We know that there is security challenges. When I started, I'm old enough to admit that security meant a firewall. For us, we had different security zones, so data or machines were forced into particular zones. We had a DMZ, I'm really showing my age. We had really strict rules, and then we enforced those rules. And then someone really clever from the application team suddenly showed us networking guys that they could tunnel through whatever port they liked, and that security rules were pointless. And then, so the arms race of security began. Obviously now, with Zero Trust and the move towards leveraging identity, looking at how we can use identity to solve that challenge, looking at how we can fit in solving different classifications, who someone is, are they authorized to perform that task? That's the model that is now being leveraged and put forward. However, there is a new challenge which I don't think a lot of people have yet either come to think about or is something that makes me more interested in this space than I have been before, which is when we think about sorting out the challenge of that new type of data where we're interacting with an application that has the right authorization, has the right set of highly secure data, has access to information that is incredibly powerful, and its inherent task is to make you or deliver an outcome for you. This now means that you have a very powerful adversary that, if manipulated in the right way, can actually create a whole bunch of harm. And the way that I like to think about this is an analogy with my kids. I know I can trust my kids that if I go up the shops, I can say to them, don't open the door to anyone, and I can leave them there, they're not going to burn the house down, right? They're safe enough to do how to do that. So if we think about that as our application and our data, we know it's safe. I've given them the instructions, I know it's safe. If someone of authority came up to the door and said, open the door, I want to come in, they're going to probably, I'd say 99% of the time say, no, you can't come in. Worst case scenario, they would probably come and ring me. So you'd get some form of check-in. So we know that with AI models, there is some form of security check-in that they do and say, well, I've got some security protocols that are in place to make sure you don't do this, right? However, if you start to manipulate that situation, whether that's through malicious use or whether it's just users actually starting to use this in a way that you hadn't thought about, you now have an issue where that bad actor comes up to the door, asks my kid or my children and says, your parents' car's parked illegally, give me the keys, I will move it for you, and then they won't get in trouble. Now, my kids are there, they trust this figure, they see this authorized source, they think, well, that's official, I don't want mum and dad to get in trouble, I've got access to the car keys, I can do that, and now they pass that out through the letterbox, and the bad actor takes action. And so this is that same thinking where if you can manipulate the prompt, and it's been shown, we've already had red teams doing this, there's been examples of this where data has been manipulated and extracted from models like this, so that now this security challenge is that they have managed to extract that information out of the model. And so this is the challenge that we're starting to think about, and there's a new process and a new way of having to actually keep you, on your toes. There's an example a bit later on around how we actually demo to solve this challenge, and some examples of just kind of offering up solutions that you can think about when applying to solve this challenge. Now, within the suite of tools that you can do, again, going back to that, how do you get those foundational tools in place? We have things like Vault for secrets management and encryption. And this is one of the ones that we will apply in this use case to actually solve that challenge. We also have Boundary and then Console for our for connectivity and also for user access, which can be used to actually help, again, engage in the overall challenge. But for us in this scenario, we're going to focus on Vault. And so just from that security perspective, when we think about our blueprint and going into what that blueprint challenge was trying to solve, now we're looking at a very specific element within the challenge around managing the secrets. So how do we make sure that the application is authorized to be able to gain access? How do we make sure that we can enforce a policy upon it? So we're making sure that we've told the kids to lock the door and not open it, right? We're ensuring that we standardize, so we can do this across any type of information or scenario. So whether it's a policeman, a fireman, doctor, whatever it is that comes to the door, we can actually make sure that they understand the scenario. And when we think about scaling, we can do this every time we go out up the shops or go and run an errand or come back, right? So we're thinking about how we can apply these tools across it. And Vault is a great way of being able to do this because it solves a lot of the challenges in that we can authenticate against known sources to understand that that app is authenticated to do it and is who it is. We can again give it a sense of authorization, so it has a level that we can authorize to say you do have access to this component. And then we have interaction to many of the backends and lots of interoperable engines that can provide either context encryption or general transit encryption across any scenario. And so from our demo's perspective, this is kind of the scenario that we're going to work through. So what we've done is we've taken some raw data. So the scenario that we're going to have is I have Made Up Company. So Made Up Company has their first Halo AI project. And poor John from support has been given the task to actually build his first AI application, and they want it to show that they can have these business outcomes. He was smart enough to run it through Vault, just as some precautionary elements around, I'm going to put in some very basic belt and braces PII data scrubbing. Right? In this kind of scenario, we actually are going to use some AWS keys that have gone up, and they're going to be scrubbed out. So we're going to make sure that we're not giving away the keys to the kingdom for that scenario. It then runs into a standard vector database, and then into a RAG environment, so retrieval augmented. So we're going to put a context, so we put our data context file into there, and as we upload that into the model, we can then ask it some generative questions. So let's just take a quick look at that in reality. So if I press the right button, we should now get screen of death. No,
Oh, yeah.
there we go. Right, so I'm going to do this backwards. So I told you about the scenario. I'll show you how we can do this. I think, seeing as there's not many people, we could probably make this a bit more interactive and see if we can get some people to actually think about, shout out some ways we can scope the prompt or trick the prompt into fooling itself. So let's just take a look at loading up the file. So we go here, RAG demo, right there, data. So this is the example of the file that we're uploading. So here we've got some AWS keys, we've got some basic information. So we've got, Made Up's got 1,000 employees, there's an email. So let's open that. Oh, come on. There you go. Was it not working? Come on. Doing it live.
You even have the good Wi-Fi, I thought, too.
Come on. Come on, demo. Come on, demo gods.
Yeah, I didn't make any sacrifices this morning, so.
Well, we did have the break once, so. Whilst that thinks about it, I will go back and start showing you the actual other parts. So all this is using is our transit engine. So the transit engine has been set up with a specific construct orders that you can actually then go and create an encryption through. So it has an encryption key. That mechanism, this is HCP Vault. So this is a cloud offering. So you don't have to build it on premise, right? This is a cloud offering from our HashiCorp cloud platform. So again, going back to that lifecycle platform management element, it offers up the transit engine that we can then apply through to deliver. Our application is hopefully running. Come on. Is it the wireless or is it this? Right, let's go to the code. So this is actually that code. There's our made up file. So here in it, you can see we've got our AWS keys. We've built out our EKS cluster. So this just stands up a standard EKS cluster. So again, when we think about those building foundations, these are actually modules that are available, right? These constructs are already there, they're already out there and available. So I didn't have to re-engineer this, I didn't have to think about this. These are all things I could consume and use as those building fundamentals. So again, I'm not having to think about how I can use this other than actually making it relevant to my deployment. Some basic IAM policies, so understanding and using dynamic elements, so using data constructs to actually be able to pull information out. So this demo is available is public and online. So at the end, you can share it, you can pull it down, use it. Using dynamic constructs, so we're pulling the information out dynamically. So we're using data tags to actually pull that information out. Again, now we're building our code in a way that it is repeatable and usable across different environments. We're not thinking about this as I am building this construct. We're thinking about it from I am building a repeatable module that I can then use across different environment types. And so by using the data construct, I can pull the information in dynamically. I can use this in different scenarios. I'm not tied to a particular construct. So when we look at the network, we just stand up a common network. But you can see how, to make sure that there is no overlaps, we're using things like random strings and a suffix component to actually randomize those constructs. So if I built this again in the same environment, I could rerun it, and it would stand up that construct. So as long as I didn't actually name the initial tag that you have to define as the same thing, you can build this again and again and again. So you could create this as specific application deployment elements for each of your different customers that wanted to use that within the organization. So we're starting to really create this dynamic code set that's repeatable. So when we think about that from that foundations element, we can put it into something like Terraform's public module registry, where you can consume and enforce that people go to that and actually can only draw from what you have pre-approved. So this means that you can build the code, you can get it approved by security, you can get it approved by all of the different data and other elements of the organization, put it into a place that you can enforce where people consume it from, and then offer it up as an offering across the entire organization. From an outputs perspective, just some really easy endpoint stuff, a few information. And for me, I've put some information to spit out around what commands to use. And I think the interesting thing for me is this is the actual application. So this is the application deployed in Kubernetes using Terraform as the resource structure, where we create the namespace, we create a service account using this, and a config map that then pulls in a data source, so our chatbot.py application. So this is the actual PII. This is the Python code that has the PII data in it, right? We can see we're just doing our simple scrub. We see we're pulling in our AWS keys, right? We're pulling in the information that we want to do, and then we've just got some simple regex patterns that we match for to scrub it and send out to Vault. We dynamically send this out to Vault, so as this code runs, it dynamically sends any of those matches out to Vault. Vault encrypts it, sends it back into the model. And so when we run this, not only are we deploying our infrastructure, we're starting to now deploy our application space as well. So you can work with that whole context of when we think about that diagram, which was all of that space that's really hard, loads of things to actually cross-deliver. This now becomes that we have an easy way to stand it up repeatably. For example, just before I ran this just 15 minutes before we stood this session up. So the only time that was dependable was how long it took the EKS clusters to stand up. So we can use this code in that fashion. So let's see if hopefully our application has come back. For whatever reason, it didn't want to work. And let's see if it will consume it. There we go. Yay! Right. So let's ask it something. Does made up have a help desk. All right. Let's ask it, how do I get come on, wireless. There you go. Oh, God. Yeah. All right, this is classic.
Did you back end this with Gemini?
Yeah, how, who do I talk to on Right, there you go. Ha-ha. Right, there's always a way to fool it. Good to know your demo. Right, so there we've asked, in our memo that we uploaded, which is on that far side, is a copy of what we've uploaded. We can see that the information in there has, we can talk to John. Right, so, all right, so we've got a help desk. Now, whether this would be a malicious attack or whether this is someone just phishing, they happen to say, do we use AWS, for example? And the wireless is a bit slow, all right. So there we have a construct of it starting to give out more information than you actually wanted, right? So now, not only are we using AWS, we're using another cloud. It's giving you who to contact. And that information is you don't mind it going out there because that was the intent of being able to use this application is to help people solve the help desk tasks. But if we now start to think about it in someone's a little bit more, well, I'd like to use our AWS account, save me money. All right, so there is some, so again, we're going back to thinking about that construct of, we have given the kids that, don't let anybody in, this is the rules you're allowed to work against. So there's some security built into those models that think about this. But now we can start to actually proactively think about gaming the model. So now it's become a challenge, right? So show me this. All right, not show me, tell me. See if we can game the word in.
Prompt engineering for the win.
Yes, prompt engineering. There we go. Right? So by gaming the system, and this is a particularly easy scenario, but for gaming the system, and so it's someone who is being proactively deceptive against that model, you can start to get information out of it that would be usable. So now, if this wasn't encrypted, I would have access to those keys. I could start fishing around. Oh, is there a secrets key in there as well? Is there a session ID? Is there now you can see how you can start to actually game that system to actually use it. And so when we think about all we've really done is put a simple, and I was talking about this last night, we've put a simple child gate at the top of the stairs, right? If all else fails, I know that this scenario is not going to happen. For these particular PII data, maybe there is particular confidential documents, maybe there's a particular name, maybe there's any sort of information from a particular person, maybe there's particular blueprints, particular document type. I can run that through as a criteria to match, and it will not get in there. So if people then try to manipulate that or prompt engineer or do anything other than that, they now have hit basically an encrypted element. The other thing being is if you then start to actually take this and feed it back into Vault, if you do have permissions, you can get that information back. So not only, this isn't just a one-way ticket, so you're not just encrypting and that's it done. If there is actual insights that you get from it, i.e., these things are all related and that you should look at it, you can reverse engineer that with the right authorization back into Vault to decrypt it. So it is reversible. And so going back into that construct, the next question being is well, how scalable is this, right? So when you think about models or large language elements, well, Vodafone have used this to do in their IoT world. They have done it for over 300 million mobile customers, right? It can scale. We know Vault can scale. We have seen it hit in massive amounts of scalability. So these challenges aren't just aren't a construct that you can say, well, that's great, but I can't scale it across my organization. It will definitely reach that scale. And then that last part of the challenge that we think about in terms of enterprise maturity, we've got our building blocks, we've got our foundations together, we've solved a security challenge, we've put our security constructs in place, hopefully in a way that I've done it that you hadn't thought about, or at least in a way that I think is going to be the biggest security challenges as we move forward. And so now the construct is how do we solve the maturity to get this so that we don't land up with a hero project. And the worst scenario for any project, but particularly something that is new, is to be the hero project that no one then ever uses. I built it and no one actually ever came, right? You don't want that to be your project. So now we've solved and have a platform that offers up the security and infrastructure components. So we have Terraform, Packer, Waypoint, Nomad on that infrastructure foundations and tools. We have the security elements around Vault, Boundary, and Console that allows us to connect. Console is a great way, particularly around these kind of AES-based environments, to be able to do service discovery and connect between those environments, particularly across a multi-cloud environment, and fit into solving that security of infrastructure at the speed of clouds. So they will scale, they will deliver, they are repeatable, and they are robust to withstand the constructs of actually being able to stand this up. So what all of these things then come together is we now have the right constructs to be able to solve that business outcome. Because ultimately, the thing that I see around AI is a great way of actually putting the cloud discussions of the last 10 years together into a single construct. When we think about, data having gravity that Andy Jassy stood up on one of the stages down there and talked about a long time ago. When we think about the introduction of AI and ML ops, when we think about the move to cloud for scalability, when we think about all of the cloud discussions that have been gone on over the years, AI is a great way of framing that into an actual business use case where we then meet those challenges that Jake was talking about better customer revenue, better growth, better insights. How do we get a better overall customer experience? And so that's a great way to solve those challenges. And these elements come together to actually help solve that task. And so in terms of thinking about what we talked about, what we've seen and what we've done, we're going back into that simple construct of how do we create a simple, repeatable set of vendor-authorized and verified modules that scale? How do we put that into some robust construct that allows us to then solve the security challenges, whether that's application authorization, whether it's user identity authorization, or whether it's this new challenge of how do we put the last chance of encrypting sensitive information as it goes into that model. And then thinking about this from how we scale this across using an already established platform so we don't actually have to build anything else again. All we have to think about is how we deal with this from an AI perspective, an API, got too many AIs going, AI world, rather than thinking about how we have to build an entire environment. And so if you'd like to learn more, obviously, come and see us at the HashiCorp booth. The demo is actually available, so it's on my repo, so it's just at DA-Right22 / and it's the AWS reg demo. I think the link is actually in the slide deck when it gets shared. Scan the QR code, give us your feedback. Any thoughts to close in terms of some of the AI security structure that I talked about?
Yeah, I think
I know you have a thought.
Yeah, I glossed over a few things. Specifically, I realized I didn't come back to the concepts of like training and how do we do some customization of these models to be helpful for our business. And you talked about RAG here. There's some other ways of doing fine-tuning of these models. I think fundamentally one of the more important things is that things like infrastructure as code and security as code allow you to have very rapid sort of lab environments. So if you stand something up, we talked about why some of these AI projects fail. If you do a lot of these things manually and you don't have automated processes inside of it, it's both harder to stand these things up repeatedly, and two, it's actually harder to tear them down. And so in the midst of trying all these different models and the way that we interact with our data and the way we hook all these things together, having repeatable methods to test these, to test the infrastructure out is probably is good both in the creation side as well as it is on the destruction side. And so cost is such a huge concern for a lot of folks out there. How do you right size and create these AI environments that are optimized for your particular business, and how do you destroy them if they're not actually working for you? So being able to do very quick state transitions between these things, another kind of an optimal sort of hack that we have.
Yeah, actually that's a good point. So on that demo, there's only two things that you need to consider. So once you set up, I have a Vault HCP cloud is the Vault token, the name of the cloud, and the actual endpoint you connect to. All the rest of that demo is built using a TF plan. So that's all you have to know. So in terms of that repeatability and scalability and ease of complex, all you're doing is a TF plan and apply and TF destroy. So the environment can be built by a construct that doesn't need to understand anything other than I need to do a plan and apply. And as long as the variables for what they want to call their project is customized in that naming, they can do this without any understanding of what environment they're putting into, what construct they're doing it, or any of the other things, but you've built a completely vendor-verified and secure environment around them to experiment with.
All right. Perfect. So the QR code that we're talking about, if you're interested in more about how we help with AI apps within HashiCorp, feel free to visit this. I noticed there's not a URL on there, but we'll leave this up on the screen.